Hi folks, so the question we have in front of us here today, guys, is a road geometry question from the DCG Leaving Cert paper, 2010 ordinary level. So the question itself says, 2010 ordinary level, the accompanying map shows ground contours at 5 meter vertical intervals. Our scale is 1:1000. So what I always do is just kind of work out. Sometimes the scale, they might throw something tricky at you like 1:500 and so forth. But just on that, so I put it in here on the right hand side. Our scale is 1:1000. Okay, that means 1 millimeter on our sheet OS is equal to 1000 millimeters IR in reality. Okay, so this is here is in millimeters. Now, what we want to work up to is, we can see the distance between our contours. If you come down here at the bottom, we can see is 35, 30, 30, 35, 40. So the distance between them, and it tells us, is 5 meter intervals. Now we know 1000 millimeters is equal to 1 meter, and we want to work up to 5 meters. Okay, so what do I have to multiply this by to make 5 meters? Multiply it by 5. Therefore, 5000 millimeters, once again, in reality, is equal to, multiply 5 by 1, 5 millimeters on our sheet. So 5000 millimeters, or 5 meters in reality, is equal to 5 millimeters on our sheet. Okay, so that's kind of like our little magic number there that we're going to use. Now, it says here on the map drawing, on the drawing supplied, draw a vertical section profile along the line AB. Part B, determine and indicate in meters the maximum difference in altitude recorded along the line AB, so the highest point to the lowest point, and then C, D and E are outcrop points on the surface of stratum 4. Determine the strike and dip of the stratum. Okay, so what we're going to do is, first of all, along the line AB, we're going to create that profile section that we need. So first of all, what I want to do is I want to identify some of the points that are on it. So I can see A is at 35 and B is also at the 35 contour if you come down here. So I'm just going to bring this down here now, so it's in the page a little bit better, and nice and straight there. Okay, and looking along that, then obviously 35, 40s, so 30 is our lowest kind of point there. Okay, so what I do is, usually, because we're working in fives now, I usually put the one that's just below it. So what will be below 30? It will be 25. So I'm going to put 25 there. And B is my furthest point over, so I'm just going to project that up there. Okay, just so I know that's the highest. There's my 25 there as well. And what I'm going to do is I'm going to measure up in 5 millimeter increments, and the highest I know it goes up to is 60. Okay, so what I want to do is mark up in fives, so 5, 10, so that'll be 25, 30, 35, 40, 45, 50, 55, finally 60. Okay, marking those up. So that's 30 and 35, just making sure I did the right one. Yeah, 40, 45, 50, 55 and 60. Okay, so I'm going to write those in: 30, 35, 40, 45, 50, 55, finally 60. And likewise on this side, 25, 30, 35, 40, 45, 50, 55 and finally 60. Okay, now what I want to do is I want to find plot the points where those contours are cut by that vertical section profile. So A, I can see, is actually on 35. So just keeping your numbers below so you can see it. So I can project the A up to the 35. The next one I can see is the 30. So I'll mark that one only up as far as the 30. Likewise with the next one, that's on 30 as well. Next one is 35. The next one I can see is the 40. Next one, 45. Next one is the 50. 55. Let's see where this is kind of going now. 60, just make sure. Sometimes you might have to just go back and check just to be certain. 60 again. Then this one, if you follow it around, is on the 55. You can see it down here. Then I assume we're going down to the 50. Next one should be at 45 because it seems we're going down here now. Yeah, and it is, so 45. And then this one is at the 40. And finally B is on the 35, which is there. Okay, so just you can actually kind of roughly see it there, but I like to do, and B, as I said, is on the 35. I like to just identify those points before I sketch in that profile. Okay, just to give me a little bit of a guide. It's a little bit more clear. Okay, so you can see there, that's my vertical section profile, which I'm now going to sketch in, so I'll speed up the video. Okay, there we have it. That is our vertical section profile sketched in. So it said on the map drawing, draw the vertical section profile along the line AB. Part B says determine and indicate in meters the maximum difference in altitude recorded along the line AB. So the maximum difference in altitude. Okay, so what we essentially want here is the lowest point to the highest point. And I'll put this in green now, so I can determine along the line AB that the highest point is here. So I'm going to project the line across this way, because I can also determine that the lowest point is down here. And from roughly the middle, as best I sketched it, the lowest point, okay, therefore the maximum difference in altitude, okay, is from here to here. And what I want to do with that line there, let's put it in a little bit heavier, with that line there is I want to measure it. So remember, 1 millimeter is equal to 1 meter, and it's coming out on mine to be 31, between 31 and 32. So with a rough guess there, I'm going to say 32 meters. Okay, so I'll estimate up. So 32 meters. If you guess 31, I'd imagine in the exam that there would have been a rough, the answer would have been 31, 32 and so forth. Okay, either one would have been absolutely fine. So that's part B done. Determine and indicate in meters the maximum difference in altitude recorded along the line AB. So from the highest to the lowest. Bringing in some real world examples there. Now, C, D and E are outcrop points on the surface of a stratum of ore. Okay, determine the strike and dip of the stratum. Okay, so anytime you get one of these questions, you want to connect up these points. So we can see that C is on the 40 contour, D is on the 30, and E is on the 60. Okay, so I'm going to connect up these points here. And what I'm actually doing by connecting these points is I'm making a plane surface. And this here is actually the plan view of this plane surface. Okay, so what I want to do is, having found a plan view of it, anytime we have to find a strike, okay, which is the first thing they ask us for us up here, a strike can only be found when we also have the elevation view, unless they give it to us beforehand. Now, I know D is on the 30, so I'll come up as far as the 30 there for the D. Switch it up from my green. Okay, C was on the 40, so I can project it up as far as the 40 meter height. And finally E was on the, just to make sure, 60, yes, up here. Okay, identify those points. So right there I have E, right here I have C, just make sure it's on the 40, yes, and then D was on the 30. Once again, just making sure. So here's my D, and what I want to do is I want to connect up those points. And essentially what I'm doing is I'm drawing in that surface there. Once again, only this is the elevation view of the surface. So it's like we're treating, you can see it here, that triangle up there, it's kind of almost into the mountain, but this triangular surface is the elevation view if we imagine this here, this line here as our XY line. Okay, and that's the elevation, this is the plan. Now a strike is a level line that is going across that triangular surface. So if you imagine this triangular surface here, it's like I have it here like this if you treat the T or the set square as the triangular surface, and a strike is a level line that is running across it. And what we need to do is we need to find the true length of that strike line. So the best way and the easiest way to do that is in your elevation, and what we do is with the 3 points C, D and E, I can see based on their heights that C is in the middle. So using C, I'm going to do a line across from C to cut the line D to E, and it cuts it right there. Okay, where it cuts it in that position, what I'm going to do is I'm going to project it down to my plan. So from here, and it cuts the line D to E. Okay, having done that, I am now going to connect that back up to C like I did, okay, in my elevation. So that elevation view there of this line, this is the plan view of it here. Okay, and as you can see there's a big difference, okay, where it's only this long in my elevation, you can see it's obviously a lot longer in my plan. Now the one that we need is actually the plan, and that one there is called your strike. So that's our strike found. Okay, and the reason as well is it is also a true length. The reason for that is because in your elevation, okay, any level line that is parallel with one of the principal planes, in this case our XY line, okay, being the horizontal plane in this view, in the elevation view, okay, because it is parallel with it in elevation, parallel with the XY line, therefore that means it is a true length in our plan. Okay, so what we're going to do now is we're going to look along that true length to determine our dip, okay, because anytime you look along a true length of a line, if you take this pen for example, if you look along that pen, the true length, okay, that's the true length as you look down at it in the camera right now. But if I want to look along that true length, okay, I have to literally take my eyeball over here looking in this direction at literally the point of the pen, and what you would see then is a point view like that. Okay, so if we see the true length as a point view, or the strike as a point view, because the strike is on the surface CDE, I'm going to see the surface CDE as an edge view. Okay, so setting up an x1, y1, this is auxiliary projection here now. So setting up an x1, y1 perpendicular to my strike, so I'm going to project that out there and set up an x1, y1 perpendicular to it. Keep it as close as I can, trying to keep it all within the sheet. This is my x1, y1, and what I want to do now is I want to project out those points parallel with the strike. So just a bit of sliding set squares here. I know D is the lowest one, so it doesn't have to come up as far. C is the next highest, and then E is actually the highest point. So that one will have to come out. Oh, just lift a little bit there. A little bit further. Okay, now thinking back to orthographic projection here, what we're going to do is if we project from the plan, we take our heights from the elevation. So D there, okay, we can see is up 5 millimeters. So I'll actually start with C because D is quite small, but just for the sake of C, I can see if I think of the contours, it was up 1, 2, 3. It's actually up 15 millimeters. So you could either measure with your compass like this for C, okay, follow down to C where it is on the x1, y1, I'm going to mark it off of there, okay, mark from the x1, y1. So there I have it, that's where my C1 is going to be. Now alternatively, I could simply just have measured up, and we know that it is 15 millimeters high, nice and easy. Okay, likewise with D, I know it's up 5. Okay, so this one's probably a little bit easier just to measure out 5 millimeters. Okay, so that there technically is D1, that's C1, and finally E, if I wanted, I could use my compass or I could measure it. So 5, 10, 15, 20, 25, 30, 35. So for E, I'm going to measure out 35 millimeters. Okay, and that there is E1. Now hopefully if we're accurate, depending on your accuracy, okay, all of these should line up in a perfect line. Let's see now. Hopefully they do. And a little bit out with my C there. Probably half a mil out, but that's okay. Just a little bit of accuracy I'll probably lose out, and a tiny bit of accuracy there. But all the same, the method is correct. So what I usually do is I continue that down then, because our x1, y1 now is acting as our new ground line. And what we have determined is this surface here, CDE, we have now found C1, D1, E1. That surface there, we have actually got an edge view, okay? So that is an edge view of the stratum. Okay, and because that is an edge view, we can actually see, and this is our ground, or what we're using to determine our ground, that is the angle there, which is otherwise known as the dip. Okay, that our stratum of ore, whatever it is, the gold or the coal or whatever you're mining for, that is the angle that that makes with the ground inside there. Okay, that is the question completed there, guys. Just as far as I'll just check, CD and ER outcrop points on the surface stratum, determine the strike and the dip of the stratum. So there we have it. We found the strike and now we found the dip. Okay. After that, then sometimes they might push you on further, and they might say that this was the stratum of the head wall, and they might ask you for, and they'll give you a point on the foot wall, and they might ask you to determine the thickness as well. Okay, and that would be just an extension on those questions. Okay, once again, guys, that is the 2010 ordinary level question from road geometry, or in this case, geologic geometry. Hope you found that helpful, guys. That's the question complete. Okay.